Hello again, this is Avkash, and in this presentation I will be talking about what is new in Windows Mobile 6.5 kernel. As you all know that Windows Mobile 6.5 kernel is based on C5 or C5.01 kernel. It means it's still using the older kernel design which use slot-based model. This presentation is in two parts. First part, I will be talking about the changes which are introduced in Windows Mobile 6.5, and in second part I will be talking about how OEM can take advantage of these changes. So the topic is Windows Mobile 6.5, what is new in Windows Mobile 6.5 kernel. Okay, here is the agenda. I'm just giving you an overview about what I have in part 1 and what I have in part 2, and part 1 and part 2 they are recorded separately. So in order to complete both parts you have to go through with each one separately and understand the content in each one. The topics for part 1 are changes with ROM DLL location, what the changes we made in Windows Mobile 6.5 which OEM need to understand and take care of in their platform build process. And the second topic will be changes in Device.exe thread stack. This is another changes we made to accommodate more and more drivers OEM can put in their devices. In part 2, this is related with taking advantage of Windows Mobile 6.5 new changes, and the topics will include efficient use of virtual memory and how to use new changes for gaining best results. So that will be the agenda for part 2, but in this particular presentation we will be talking about part 1, the changes in Windows Mobile 6.5 kernel. The topics are changes with ROM DLL location and the changes into Device.exe thread stack. So once the agenda is clear, we will go to the next page. So as you all know that Windows Mobile 6.5 is an extension of Windows Mobile 6.1. So what we will do, we will go through with the changes we have in Windows Mobile 6.1, and then we will add the information top of it that what has been added in Windows Mobile 6.1, then it's called Windows Mobile 6.5. As you all know that Windows Mobile 6.1 has a little different virtual memory management, and when I say different means that we have about 64 slots to use 2 GB memory. Then we are using slot number 59, slot number 60 and 61 in a different manner. So that's the another change we added. And then the module DLLs which are all over in slot 0, slot 1, slot 60 and slot 61. As you all know that the DLLs are loaded in slot 1, and those are all ROM DLLs. And those who knows about image building procedure, there are two locations to place the DLL in the image. One is file section and another is module section, and there were limitation previous Windows Mobile 6.1 previously that module section was really very small and only a few DLL can be loaded, and there are really good advantages of having module section, and which we are not really talking. If you need to understand, you need to look for my previous presentation about C kernel, which talks about the differences between file and module section. So the advantage here that you have module DLL, they are spread all over slot 0, 1, 60 and 61. Then these slots can provide really very fast access or the fast way to load these DLLs, and because of this design it really improves the DLL load speed. Besides that, there is another advantage we have, that we can really make the platform build process comparatively easier, because previously you have to put modules in file section, then modules in then DLLs in module sections, and DLLs are in file section. But what you can do, you can really add all these DLLs in module section. This is another advantage which is 6+1 6.1 above. And we also made some changes that DLLs, they were 64 KB aligned, then in some areas the DLLs are 4 KB aligned. not everywhere. There are some areas where they are still 64K aligned, but we have got some new areas where these DLLs are 4KB aligned. Okay, so just this is a slide which just gives you a quick information about the slot design. So as you all know that C5 based kernel, it uses a 2 GB virtual memory divided into 64 slots, and here is the design. And then because we are using slot 59, slot 60 and 61, so here are the addresses, like the address range you can see in the screen, and I will try to put the mouse close by here. So you see that slot 59 has a virtual memory address range start from here to here, and then slot 60 and slot 61. Okay, we can go to the next page now and review file and module section. So here is a quick review about your module section. In module sections, DLL are allocated in virtual memory during build process. So when you are actually building, the virtual memory is really allocated for this DLL to the build time. So when the device boots up, it doesn't really need to fix up that memory. Okay, that's why it doesn't really need to fix up during load. It provides a faster loading mechanism comparative to file section DLL, and module section DLLs are aligned with 4 KB boundary. So that's another good way. It means if you have two DLL, one is 4 KB and another is 7 KB, in that case you are going to use 4 for first DLL, and because second one is 7 KB, then you can have a 4 KB aligned boundary, then 8 KB. It means that's going to take 12 kilobyte of memory. Same if you have DLLs in file section, one is 4 KB and another is 7 KB, each one going to take 64K. It means you have to use 128K virtual memory to load this DLL. So that's the difference if you have a smaller aligned boundary. File sections, the DLLs are allocated into virtual memory during runtime. So when the device run, all these DLLs are loaded, and then the virtual memory for these DLLs are actually allocated during that time, and that needs fix up during load, and that's a slower loading process than the module section. That's another, and the biggest factor, because these DLLs are 64K aligned, and which I have already explained the difference between having a 4K boundary versus 64K boundary. Next, virtual memory management, which is applied to Windows Mobile 6.1, and the next slide will tell you what is applied for 6.5. That gives you an idea that what was in 6.5 and what changes we added to make it Windows Mobile 6.5. In Windows Mobile 6.1, we had two new virtual memory slots, 60 and 61, to handle 5 DLLs. And keep in mind, in Windows Mobile 6.1, the slot 60 and slot 61, they were not handling module DLL. And in Windows Mobile 6.1, we also had this device stack. It moved to a new slot, which is slot number 59. So when those who really work in driver development and they try to debug the image, they can see that the stack in the threads inside Device.exe, they show a very different base address comparative to the previous, where the Device.exe slot, which was number 2, and then you can see the addresses start from different virtual memory range. So here you have a total new place to place the Device.exe thread stack. And in Windows Mobile 6.1, it also has the more efficient use for virtual memory space, because all these changes, they made a very efficient use of virtual memory space in Windows Mobile 6.5. So the changes what we have really added, they include the previous slide content and something new. So we still have slot 60 and slot 61. They handle file DLLs, and these slots are also handling module DLL. That's the one of the biggest changes we made it. And slot 60 and slot 61 accept only read-only DLL code. So as you know that there is a code and there is a data section of these P format based module. So slot 60 and slot 61, they really accept only read-only DLL code, and read and write section of the DLLs are still allocated in slot 0. So if you have a DLL which is really placed in these modules, so the read and write section of that DLL will be allocated in 0. However, the read-only module or read-only part of the DLL code will be loaded into slot 60 and slot 61. So that's the changes we added in Windows Mobile 6.5 top of Windows Mobile 6.1. So let's see what is in next slide. So this talks about the changes what we have made in this, as described in previous slides, what really adds up, what the advantage it brings to OEM as well as the mobile device user. So very first thing I would talk about execution stability. Previously, the code and the data portion of the running process was distributed. Now the complete code and data portion of the current running process is located in slot 0. That improves stability. That's a really very easy way to describe. Previously, if you remember that when you were running your process which was in slot 0, and that code and data portion was actually in different area, and because and this new change really adds up that the code and the data portion for the same running process stays in slot 0, and that's really changes a lot in terms of process execution, memory management, and it improves the stability. The next topic I would be talking about the simplified platform design, that talk about the placing DLL either in file section or module section. So previously a few DLLs were part of module section. However, most of the DLLs in the OEM platform, they were all part of file section. Now OEM can list all of their DLLs in module section, and actually they can totally ignore the file section. So everything in module section, there is only one simple header in bib file to place all DLLs in module section, and there are a few registry also available which really make these DLLs which are available in all module section to load them properly. Okay, the another advantage of having this new virtual memory design is a DLL load performance increased. As we saw in earlier section that DLLs can be, during image build time, DLL can be designed to place either in file section or in module section. And we also know that the DLLs which are loaded from file sections, they perform slow, and the reason because during load time the address has to be fixed up. However, the module section DLL, they really don't need to do all that fix up part, and they really load faster, because in Windows Mobile 6.5 all the DLLs can be placed in module sections that help in three different ways. First, module section DLLs does not need fix up, so the address fix up during loading is eliminated. That saves time, and that really saves time as well as it improves performance, because module DLLs are loaded faster because of the reasons which I have described earlier. Another advantage of this new Windows Mobile 6.5 change, that it provides a better virtual memory management. Previously, most of the DLL were part of file section, and because file section DLLs, they have a 64 KB boundary alignment, and they also need fix up. But if you place all the DLLs in module section, then what can happen, because module section DLLs are 4 KB aligned, and this alignment provide a very granular way to manage the virtual memory, and there is very less wastage of memory. If OEM will use a very smart way to build their DLL, and then they can really use this new change to make their virtual memory management really robust. It is up to OEM to take the advantage of this change. Yep. And more and more DLL can be loaded into device, because if you have this way, you can, the Device.exe can really load more DLLs comparative with the previous Windows Mobile 6 type of platform. Okay, after this we will see the next slide, which gives you the cumulative information what we have talked about in previous couple of slides. It gives you a summary of the memory slots in Windows Mobile 6.1, 6.5, and even before 6.1. So the first line in this table shows that slot 0 and slot 1 DLLs, they had the file and module DLLs. Slot 60 and slot 61 was not really available for this DLL. Please remember that first line is for Windows Mobile 6.1 and before Windows Mobile 6.1, sorry. And the slot fill order was this way, that file DLLs will go in slot 0, then module DLL will go in slot 1, and then after they go to slot 0. In Windows Mobile 6.1 to 6.5, still slot 0 and slot 1 DLLs, they were part of file and module section, and slot 60 and slot 61 was introduced in Windows Mobile 6.1, but only file section DLLs can go there, and the file and the slot fill order for the DLLs was that file DLL will go first in 60 slot, then 61st slot, and then 0, and the module DLLs, they start from slot 1 and the slot 0. In Windows Mobile 6, slot 0 and 1 is available for files and module section DLL. Slot 60 and slot 61 is also available for file and module section. And as I mentioned earlier, that actually in Windows Mobile 6.5, OEM can take advantage of filling the module section with complete all of their DLL, and they can completely remove file section at all. And the slot fill order for Windows Mobile 6.5 is that file DLL will go into 60, then 61, then 0, and then module DLL, they will go from slot 1, then 61, then slot 60, and slot 0. So if you remove the file DLL, just an example that OEM build an image which has all modules in all DLLs in module section, then they can take advantage of second one module, then DLL will place in slot 1, then slot 61, and then slot 60, and then finally in slot 0 as if needed. Okay, so here is a best practices, and actually this is a really very quick detail I would be giving in reference to the discussion we just had in previous couple of slides. A detailed information is also available in the next part 2, because this particular presentation includes the changes as well as the information about Device.exe thread stack. So this is just a capture, I would say, that what the best practices are to take the advantage of virtual memory changes that use module DLL instead of file DLL, because it loads faster and if they have 4 KB alignment. Reduce code size in the DLL for the DLL which are in the slot 0. So if you have a DLL and if you can which are going to go in slot 0, try to reduce the code size in the DLL itself, and reduce data size because all the data is in slot 0. So you also need to review this part as well. Okay, here is another best practice, virtual memory. And what you need to do, you need to consolidate the multiple DLLs into one DLL, because if you have a 4 KB or 64 KB alignment, just think that not in context of file and module section memory alignment. Just try to look for have this mathematics that if you have a multiple DLLs, they are range between 4 KB to 64 KB, but if you have the alignment scheme which is fixed for 64K, then for each DLL under 64K will going to take minimum 64K virtual memory. And same if you have a DLL between 64 to 128, then it's really going to take the 128K. So it's a multiple of 64K. So it's better to combine a few DLL and then make one DLL which is pretty much closely aligned, like it's going to hit the 64K or multiples of 64K boundary, same as 4K and multiples of 4K boundary. That reduces the waste of virtual memory. Okay, and when you are consolidating multiple DLLs into one, that also help you to reduce the data size for the DLL which is going to go in slot 0. And one thing to remember, that for a DLL which is in file section, the code and data which is also aligned for 64K. Okay, if a DLL is moved from slot 0 to slot 61 and slot 62, what the best practice for it is that enlarge paging pool to avoid performance loss during allocating DLL to paging pool. So what is actually happening when your DLL is really load, it really use the size defined for your paging pool, and all these DLLs they really load there. When DLLs are not in use, they paged out, or depend on your design that if the DLL can be paged out or not. But if it can be paged out, then it can be paged out as well. So if you have the larger page pool, then it can reduce the time to allocate, like paging in the DLL code there and then paging out. So you can have the little bit larger paging pool to avoid this the time which is really taking to allocate the module in your DLL in paging area, or in other words, to say like when it's really paging in and paging out, you really don't need to page out a lot if you have the larger page pool. But you also need to consider the page pool, what can be the maximum, because it's not like you can really have huge paging pool in these mini devices. Okay, here I really added a few slides which gives you a little more information about that why we really need to care about slot 0. This is for development perspective, and it's also really good to know, because if you are writing a driver or if you are building an image, why we need to care about slot 0. As you know, slot 0, the size 32 meg, and every dev, every image, every engineer who is building Windows Mobile images, they want to place their modules in slot 0. Yeah. But if you think that it's not really true that you can put every DLL in slot 0, and because it's not possible, and then second, because it has a finite size which is 32 meg. So that's why. And then if you remember why we are doing all that moving to slot 60 or slot 61, because we are really running out of space in that slot. That's why we are spilling over, and then we are looking into other slots, and then we found slot 60 and slot 61 to take care of the problem. So the truth is that not every DLL can be placed in slot 0. However, you can take the advantage of placing a few DLL in slot 0. So there are two things to take from this particular slide. Keep in mind, it's not slot, it's this slide, that you have a way to place a few DLL. You can force image build or DLL load process to keep your whole code and data section of DLL in the slot 0. That's the one thing you can learn from here. Second, you cannot put every DLL in the slot 0. Okay, so the question comes, okay, if I really want to force a DLL or the code and data section of the DLL in slot 0, then what I need to do? Then I can say, okay, because you have two ways to place a DLL in the image, either through module section or through file section. And as you know that module section is all these virtual memories really assigned for this DLL during build time. It means that if you really need to force, then you need to do something during build time. It means what you are going to do, you are going to place an option called L in the bib file. So when you define that your module name in the bib file, you will also add a flag called L, which will let image build process to know that this particular module needs its code and data section to be placed in slot 0. Okay, that's the way you are going to make a module DLL completely in slot 0. Now the question comes, okay, so what about file DLL? And for the file DLL, we can actually do this thing in a registry, because the memories really assigned for file DLLs are during runtime. So in the next slides, here is the way you can do things in registry. What you will do, you will set your DLL name equals 1 in the HKLM system loader load module low. It means that please keep the code and data section of my DLL in the slot 0, and if you have a few DLL you would like to place the code and data section for these DLLs in the slot 0, then you will create multiple registry for each DLL and set the value dword1 for the each DLL, and this way you can really force a DLL to be placed in slot 0. And as you remember, if you will go back a few slides, then you can see that the module DLL load order is from 1, 60, 61 and 0. That's why we are really going through with this exercise. Okay, so I think that would be the about for module and file section DLL to take the advantage of this new 60 and 61 slot. Next come, okay, what is the talk about Device.exe call stack, and what the changes we have really made. So it started from Windows Mobile 6.1 and above, every thread in the Device.exe is using the virtual memory from slot 59. So this, if you know that in the slot based model the Device.exe is loaded, it used the its thread stack or the virtual memory for the thread from its own parent slot where it's really loaded. But from Windows Mobile 6.1 and above, the thread is going to use the virtual memory from the slot 59, and the base address for your information for this slot 59 start from hex 7600 and 0000. And by making this change, what we really got? First, because Device.exe load almost every driver in Windows Mobile, Device.exe can easily run out of virtual memory. Okay, and by making this change, we can place more DLL, more driver DLL in the Device.exe, and we can give more virtual memory to Device.exe. And using this process, we have got about 8 megabyte of virtual memory in the Device.exe process, and that's really a good amount of space to place more DLL, more driver DLL, to load more DLL in Device.exe. And what we actually lose by changing this, because the higher range of 2 gigabyte virtual memory is really fixed for memory mapped file, or something called large memory addresses. Virtual memory allocation for Device.exe thread stack. So how it really works? So kernel determines from the thread start address that what module the thread is located in, and because it just looks into the address, and once it finds out, oh, is the thread stack which is coming from Device.exe, and immediately try to look and try to load in slot number 59. And actually there are a few exceptions. It means you can really force that, oh no, for this particular driver DLL, you can request to the kernel that don't move the thread stack from slot the slot for Device.exe to the slot 59. And then what the exception is, I will be talking next, that how you can create this exception. And if there is no exception found, then that particular thread stack just move to virtual memory which is available in slot 59. And if the allocation fail, then kernel tries to allocate virtual memory from the current process back. And so how I can consolidate the information from this slide, that kernel, whenever there is a Device.exe, there is a module loaded in Device.exe, kernel looks based on its address, immediately try to look the exception list and say, oh, can the thread stack for this module be pushed to slot 59 or not? If there is that DLL is not available in exception list, it will try to get the virtual memory from slot 59. By any reason, if it can't get, then it will try to use the virtual memory from the parent slot for Device.exe. That's the way. Or if the exception found, then it will try to use again in same Device.exe virtual memory base address. Okay, then how it works in Windows Mobile 6.1, that changes in 6.1 plus means 6.1 and 6.5, that change is already added by default, so OEM really don't need to do anything, it is already done by itself. However, OEM or driver developer can change this behavior. They can disable completely. It means, hey, don't use slot 59, do everything in slot the Device.exe slot, or disable per module means you can define that these modules, they will be using Device.exe virtual memory for a thread call stack. Otherwise, rest of the DLLs, they can use the virtual memory from slot 59. And to disable completely, what OEM really need to do it, to disable this feature, they just need to select this registry, select the load high equals 0, and once the registry is set for load high, then this kernel is not going to use the slot 59 for Device.exe stack thread. And if OEM really need to use the slot 59 but not for all modules, then they can define the DLL name, and they can also define the value, the word 1 for every DLL, but they also have to have this registry load high set to 1, means they need to have the minimum 2 registry 1 load high to enable the use of slot 59 for Device.exe virtual memory for a thread call stack. And then for every DLL they would like, they can really put in registry, so then it won't use that exception. So how it works, let me make it clear, maybe you are not clear the way I really explain. So you will set the load high equals 1, means yeah, please use slot 59 to Device.exe thread call stack. However, you can add a few registry for each DLL which you don't want their call stack to be placed in slot 59. That's the way you can really make it workable in your system. So actually that was it. So you went through with the changes in Windows Mobile 6.5 in kernel, like using the slot of 60 and 61, and the changes to place all the modules, all the DLLs in module section, and then they build the image properly to take those advantages. As well as I also explained the uses of slot 59 for Device.exe thread call stack. So that was it. In the second presentation, I will be talking about the taking advantages of these changes, as well as what's the efficient way to use the virtual memory, and how you can use these new changes to gain the best results. So that would be the part 2. And as always, I really appreciate if you send email or call me back, and if you have anything to add for this presentation. As always, your feedback, your comments are very welcome. Feel free to send me email, and I will try my best to accommodate your suggestions in my next presentation. Once again, thank you very much, and it was fun to create these presentations.